Oh, you might have to set the oh here. You don't need to talk in class, right?
Probably not as much.
Okay, so I think it's time for us to start.
Use that.
We have almost
Connect the shaw go.
the full class in. Can you see my share screen okay? If a few people can give me a quick yes or no. Yes, excellent. Thank you. Thanks everyone. Alright, so let's go. We are in chapter 2.3 and we are basically continuing from where we left off yesterday. And today we will be talking about specific techniques to calculate limits of different functions.
Yeah, I have like one bar. Three, two bars.
Why was it unable to connect? Troubleshoot problem. What are they talking about? Um, it's not making any sound right now.
So we'll start with a few simple rules and then gradually combine them to get more sophisticated techniques. So we'll start with linear functions. Basically, if we have a line on a graph, so f of x is some m x plus b, the familiar linear formula with m being the slope and b being y-intercept. Then if we designate a point A, just like last time, right? So to calculate a limit, we need to designate a point where we want the limit. Then we can approach A from the right or from the left, and following the function is very easy. Because it's linear, the progress is obvious. The closer we get to the point A, the closer we get to the value f of A. So f of A is going to just be m times A plus b. And this will also be
What do you do that warrants the need
the
for?
lim
What? What do
of
you do
f
that warrants the need for?
of x as x
What
approaches
shows them like?
A. And this is following the definition we set down yesterday. So the closer we get to the point, the closer we approach this value. And since we can absolute this value, this is our L. So we can call it the person who just joined in suddenly trying to speak. Their mic is very noisy. Oh, that's Avery. Avery, you are not coming across clearly. All we hear is noise.
My phone. It's gonna die, and I won't be able to contact anybody.
Okay, well,
You can plug it into your laptop.
Is something wrong?
I don't have anything to plug into. What we can do is, oh no.
No.
I
Avery,
could
would you
go.
like to say
Grab a
something,
USB-C
or
charger and
will your mic just?
Yeah.
Oh no, I was just trying to turn off my microphone.
Oh, please try
Oh, okay.
I
So
didn't
yeah, if
realize.
you don't need to speak, it will be great if you keep it muted. Okay.
You're using it for class.
Yeah.
Okay. So we're going back
Go ahead.
to the
It's
notes.
kind of short.
Any questions
Okay.
about the linear function?
Goodbye. I'm recording this too, so.
Are they saying anything important to start? Nope, this
All
is the
good?
right short.
It's just
Okay.
basically going through the notes.
Then now we'll put down a set of rules that will work
Why
for
won't it work?
different functions, not just the linear ones.
What does yours look like? Oh, it's mini.
And right now you don't have any rigid proof for any of this. We will be using them without proving them, and later
The
on
speakers,
we
like,
might
are
prove
kind of
some of
quiet.
them as we
Okay.
move along and gather more tools.
Alright, turn
So,
your volume all the way up.
What's
one
up?
On your laptop.
It's all the way
is
up?
Alright,
that
grab
lim
the control box on the
as
headphones
x approaches
Okay.
the designated
and push
point
all the way
A
that way.
of
What's
f of x plus g of
It's
x.
all the way that way.
So
It is.
the limit of a
And
sum
all
of
your volume
functions
options are turned to the max.
Yep.
would be lim dot x approaches A
What
of
is this
f
count one?
of x
Yep.
plus lim as f approaches A of g of x, given one very important provision. So to be able to break up the sum into a sum of two separate limits, we need to make sure that each of these
Limit loss.
actually exists in its own right.
I'm recording it. Don't worry. But I learned this in calculus and I remember limit
This
loss.
is very, very, very important. There are numerous tricks that you can do where the limit of the sum exists, but each of the limits separately doesn't. Okay? So a pathological example can look like this.
Alright. I should have kept all my calculus notes. I was going through my papers and I was like, I won't need any of them.
Say f of x
My little
can be
sister
1
does,
minus
won't need any of them.
1 over x, and g of x
She's not gonna do
can be
calculus.
1 over x.
She's gonna get
And choose x and choose a to be 0. So you obviously see what is going to happen, right? So when we sum these together, we get the function that is just the flat function 1. And obviously the limit at a equals 0 exists, is just the value 1. This is what the function is, equals at every value. But if we break them up, each of these limits separately will no longer exist. So it is really important that you remember this provision. It is true that in many cases it will be virtually trivial, but just like any other step, before you take the step, make sure it's a legitimate step. Okay? Questions about this one? No questions?
Sorry, I have
Go
one.
ahead. Yeah,
So
go ahead.
just to confirm, once you break up this function, if of say g of x plus f of x, it works out to be 1. But once you break it, like say it's just f of x or g of x, I know g of x after 1 over 0 that doesn't work. So does that mean just the limit doesn't exist in if you break it up in this case?
So what I'm saying is that in this pathological example, it will not be okay to break it up because
Oh, I
it
see.
simply won't work, right? So the left-hand side will exist, but the right-hand side won't.
Okay, I see.
Right? So yeah, exactly like you said.
Okay,
For
sure.
this equality to hold, both sides have to exist. Each limit on the left and both limits on the right have to exist, each in its own right.
But later
Okay,
it'll
I
get
see.
harder.
Okay?
Thank you. Yeah, thank you.
Excellent. Any more?
Does that mean that the combined limit, the limit of f at x plus g at x, that limit doesn't exist?
Oh, it does. I mean, obviously, if you combine them, the 1 over x goes away, right? I mean, the new function you get already forgot where it came from. So the combined function is simply unaware of these. They're gone, right? So your new function would be just 1.
Okay,
right?
that makes
So
sense.
if I define h of x to be f plus g, that will be simply the flat function 1. And that function will have a limit at any designated value you choose.
Fine? No, I just have no idea.
So whilst this function does have a limit, each of these don't, and therefore this equality will not hold.
So we'll have
But
this recorded.
this limit
we'll have
will
her
exist.
notes,
Yeah, the limit for h will exist.
and we'll have Mr. Morgan's notes.
Okay, just the equality won't hold.
Yep, thank you.
Good? Okay. Now we'll simply add a minus here and a minus here, and that will work as well. So what works for the sum will also work for the difference, simply because we can take a new g and call it minus g. Okay? So the sum and the difference work in exactly the same manner. Now let's move to a more interesting rule. So this time, lim as x goes to a of some constant c times a function f of x. So this is a const. This will equal c lim as x goes to a f of x. And again, the lim of f of x actually has to exist. Okay? So it's the same provision that will repeat over and over again. So that's not very complicated. Basically, c is just a number, and the number can be pulled out of the lim. Okay? Rule number 3. Lim as x goes to a of a product of two functions,
What?
f
So unflavored.
g.
It doesn't have any sweet.
And we can put brackets over everything just to emphasize that this is the limit of the entire product. Will be lim x going to a
Either that or mine's just
f of x
Well, the more you let it steep, the stronger it gets, I think.
a c of x under the same provision. So each limit has to exist.
I know, but the tea bag was in there the whole time, and it was still less flavor than I usually have.
Mm-hmm. It also might have been less hot water to begin with.
Now, how about you concoct a pathological example where this will fail? Something very similar to what we did with the sum will work here.
What does pathological example?
I know. It's just like, why is that your word to use? Like, I've never, Mr. Morgan didn't use pathological once.
All I know is pathological liar.
Yeah, I know. It's just like,
So come on, give me
such a vague way to explain that.
two functions,
Pathological example.
f of x and g of x, such that, and a designated point, such that the lim of the product exists, but the separate limits, at least one of those limits doesn't.
What does pathological?
You can make f at x x over 1 and g at x 1 over x.
Yeah, that will work beautifully. So let's choose this to be x and this to be 1 over x, and the designated point is obviously 0. Okay, so you can see that the product will give 1 and the limit on the left will easily exist, but on the right this limit will exist but this limit won't. Okay, everyone is good with this? And now let's put together something similar for the quotient. So lim as x going to a rather than a going to x. So lim as x goes to a, f of x divided by g of x will be lim as x goes to a of f of x divided by lim as x goes to a of g of x. And again, both limits have to exist. And this time,
is so bad.
there is another provision.
Like
There's another
supply
condition that
them
we
with
need.
good mics.
So the lim
Or they would just
as
find
x
like just because they care about their
goes
students.
to a
I wonder if
of
Discord you
g
can
of
turn up
x
their volume.
cannot
No,
equal
like it's
0.
literally a muffled mic. It's
And this is for
Xbox 360.
the obvious reason that
Like-
if it does equal 0,
like listen
then
to this.
we will be dividing by 0, and that's not allowed. Okay?
It's not very clear. It's very
So far, so good?
like just yeah.
Any questions about this one?
When a limit exists? Yeah. Okay. So you gotta figure that out first.
Nope. Okay, then let's move on.
Well, you have to figure out
Now,
first then you can use
we'll have a rule for the power. So lim as x going to a, f of x to the power n will be lim as x going to a, f of x all to the power n. Now this rule is actually following from this one, from the product. So this is basically a product of f times f times f n times. So we can apply this, and this is exactly what we'll get. So this follows from 3 by choosing g of x to be f of x n times. So the same provisions that were required for the product for number 3 will also be required here. Okay, and one last one. For the root, lim as x going to a, f of x to the power of 1 over n. And this n will presently discuss what it must be. That will be lim as x goes to a, f of x to the power of 1 over n. So we need several things for this to hold. not only the limit must exist like before, we need to have that f of x is actually positive near x equal a, and we need n to be even. So either this holds, or if n is odd, then we don't have a problem. Okay? So imagine a function like the square root. So then n is 2, and therefore f must be positive for us to be able to compute that root for the function to be defined. On the other hand, if this is the cubic root and n is 3, then we have no problem with the sign of f. Okay? Any questions on this one?
Could you go over that again, please?
Sure. So if n is even, then f to the power 1 over n is not defined if f is less than 0. Right? So example, square root of x. Yes? If n is odd,
It means
then f
like
to 1 over n
I guess we don't. It's like
you don't really
exists
know.
regardless
it's like
of
it's like
sign.
past infinity or something like that. I don't know. It's like any
So this
zero
time we
divided
can
by
take an
anything. I'm
example
pretty
of
sure is undefined.
the cubic root.
Oh no, anything divided by 0. Sorry.
Is that clarifying it?
They only have the
Yes,
hot
thank
water
you.
hooked up to the sink. It honestly
Okay.
felt like they
And now we can use these to combine. We can keep combining several of these and create more rules. Okay. For instance,
Hey, Will,
let's
you want the rest of my
combine
burrito?
the sink, yeah, the cold water is like 2 pulls up, but when you took the hot water, it's like
sum. So that's one. Combine
just like
combine a power, which is
yeah, but it's
a
just stronger
5,
when you have it cold. So yeah,
and combine a multiplication by constant, which is 2.
Do you want my burrito, Will?
And tell me, what kind of
Hey, you
function
want this?
will we get if we allow a summation and subtraction of powers multiplied by constants? What will that be? Something like 2x squared plus 5x cubed minus 7x. What kind of function is that? Let's go forward. Yeah, quadratic is one of those, but allow yourself to include any power.
Polynomial.
Yes. Okay, so we'll get polynomial functions.
She's writing better today than she did yesterday.
So basically p of x
Like, I think she might have upgraded
will
her computer.
look
since
something
yesterday.
like a0 plus a1x plus
Like, it's not lagging nearly as much.
x squared plus until we get all the way to an x to n. And the lim as x approaches some designated value a of p of x will be simply p of a. All we will have to do is substitute the value a into all the occurrences of x and use these three rules combined together, this is what we will get. Okay? So far, so good? Okay, now let's combine number 7 with the quotient. And the quotient was which number? 4. Okay. So this will be, so our function f of x will be a ratio of two polynomials, p of x divided by some q of x, and this is known as a rational function. For, I guess, the reason that any value of x you choose, you get a rational number for the value. And name of that as x goes to some value a of p of x divided by q of x will be simply p of a divided by q of a, provided that q of a is not 0. And obviously we inherited this condition from the quotient rule. Okay?
Everybody keeps honking.
Yeah, I know, right? I don't know, it never happens.
I realize people honk this much.
And now we'll put one general rule for all of these. And this will be whether all of this holds for the one-sided limits as well. So far we used, we referred to limits that were two-sided, so the full limits. Now let's, for a moment, consider what is going to happen if we only look at one-sided limits. So basically, all of these rules will hold regardless. All we will have to do is to put x going to a plus or a minus, depending on which limit we want to consider.
Oh, by the way, Kay, do you want this sweater? It's too small for me now.
No, not really.
Figured.
Not cool enough, Dalo.
It's Volcom though.
No.
And it's a nice color.
It's nice teal.
It's a nice
Welcome
teal.
now.
I wish he doesn't want it either.
I have too many sweaters. Yeah, I do too.
It's fine. I'll just have to find another small friend.
I might apply to the small friend council.
I could get a girlfriend. That's what I could do with this thing.
So basically, we replace x going to a under each limit sign with x going to a plus or x going to a minus. Obviously, this has to be consistent. Okay, so you cannot replace some but not the others, and you cannot replace it once with this and the other time with that. So as long as you are consistent, it will work.
A is like the limit for the x-axis, right? Like it approaches A or whatever.
I think it could approach any variable.
Just be careful with that root one, okay? So the only one that requires a little bit of caution is number 6.
We're gonna together make it make sense. Yes.
What was your question? Like, what exactly is A? What are you talking about? Like x approaches A. Any x values. So when x approaches any x value.
Oh yes, thank you. X
Basically, your
approaching
job is to make sure that
A is.
whatever you try to take the root of is positive if n is even.
The limit is
only y actually.
X approaching A is just X approaching a point. A is any point.
And then the answer is the y.
So like
Yeah, the
it
limit
means
is the
it's
y
like
value.
it's like as
So
it
the
is like
argument
almost on
of
that
the
point,
root
but it isn't
function.
actually that point. Like it's just along that.
And
Like
the limit is the y where the y is of that point on the line.
not 100%.
Must be
I
positive.
can't. I barely remember this.
So I think this covers our chunk of theory for today. And let's stop here for a minute so that you can consider the whole thing again and see if you want to ask any questions before we move on to solving examples.
This teacher actually gets stuff done. It's like I wish all the teachers were a little bit like if she had a better mic, she'd be a good teacher.
I kind of want to ask her about the polynomial thing, but I feel like she's going to ask me a question, and then I'm not
Questions,
going to
anyone?
answer it. It's gonna suck.
So just to clarify, Rule 7 and 8 are just a combination of the rules.
Of previous ones, yes.
Yeah.
But they will allow you to skip steps. So
Okay.
they are useful in their own right.
Oh, these are rules.
Okay,
1, 5,
awesome.
Those are the rules she's going
Yeah.
over.
Wait, what do you
Those are like specific numbers. Look at number
Anyone
7
else?
on polynomial function. It's like combine 1, 5, 2 polynomial function. I thought that was like combine the numbers 1, 5, 2. No,
Yeah.
she's saying combine rules 1, 5, 2.
That makes sense.
Okay, if there
Now it
are
makes
no
sense.
one,
Be
if
careful
someone
with
else is
6.
typing
I
up
thought
with
that was like,
questions,
okay, the number 6.
let's move
like,
to problems.
6 in the equation. No, it'd be like be careful of rule numbers.
Yes, that is true. Okay, now we're going through some examples.
Pathological example.
And the
Not
first
another
one
pathological example.
we'll do is that f of x
Pathological.
is this split function
That's psychological, by the way.
What is pathological?
minus 2x
It's something to do with
plus
nature.
4 when x is less or equal 1. And it is the square root of x minus 1 when x is
The
bigger
study
than
of
1.
disease.
And what we want is to find
Guys,
lim as
the
f
definition for
going to 1 minus
pathological
of f
is
of
of
x.
pathology. And
Lim
pathology is the
as
study
f
of disease.
goes to 1 plus of f of
Makes
x.
literally no sense.
And lim as f
You keep using
goes
that
to
word. I do
1
not think
of
it
f
means
of
what
x.
you think it means.
Okay,
She
so this
literally
is
says every
the
single
job.
a pathological example of that.
So let's get to it. Basically, we have 3 separate limits,
What is
and
In calculus, so
let's
like
get them
in
one by one.
calculus.
So for lim from the left,
is used in mathematics to refer to an example specifically conducted
basically the definition is split for us. It's really simple.
valid properties.
1 minus says we approach from the left, and that means we have to use this definition because this function, this is how it's defined for x less or equal 1. Okay, so use
I'm pretty sure that's illegal.
minus
She could get fired
2x
for that.
plus 4. So what's the lim?
It's against student laws first.
Wait a second, did I do limits? Is limits the thing where you check the left and the right?
You can either use the linear rule, or you can use the polynomial rule, or you can use the combination of the rules that gets you the polynomial rule. But all of them will lead to exactly the same
Okay.
to the same result. So basically, as we approach 1,
Oh yeah.
x gets closer and closer to 1. That means we can basically plug it into that function and see what's the value that we'll get when we actually reach 1. Okay, so we'll get minus 2 multiplied by 1 plus 4. That will give us 2. Okay?
Where'd that come from?
Now for the other one, So lim as x is going to 1 plus.
How'd she get 2 from that?
This time we will
How'd
have
she
to
get 2
use
from that?
the definition for the second part of the function. And although, see, the 1 here is not included in the definition of this specific function, but we know that this one, we
x
can
is
plug
approaching
x equal 1 in,
So
and we can also graph this, right? So if we put this on a graph,
wait, it's 1 negative, which means it's approaching from the right.
this is the point 1, and this is the root.
I think.
So this is x, and this is
How do you
1
get
minus
negative
x
2x plus 4
square
equal
root.
2?
So we approach this point from the right.
Why is it
The
negative 2x
closer we
plus
get
not being
to
negative 2x?
x equal 1, the closer we get to the value of this function. And what is the value?
Times 1. So, because 1, you input 1 for x. So you times 1 times negative 2, and then the negative 2 and the negative 4,
Why are we,
and then 4 equal 2.
Come
why
on,
are we
you know that
inputting
answer.
positive 1?
Because it's not negative 1, it's 1 negative. So the negative means what way it's approaching from.
Whoa, okay.
So it's a 1, it's still a 1, but when it's a negative, I think it means it's approaching from the right.
Okay, okay.
Does that make sense?
Yeah, yeah.
What
And
do I
if
write?
it's normal,
What
it's
do I write here?
just a point. But if it's positive, it's approaching from the left.
0.
Negative approaching
Yes.
from the right.
Okay. Like that, so negative would be.
Okay.
Let's go with it.
So we already found two of
okay,
these limits.
yeah.
And now tell me, what is this? What is the third one that we were requested to find? What is this?
I like how I
It
did, like,
doesn't
plain movements.
exist
It doesn't exist. Can you please give us a good sound reason why?
because the left limit is 2 and the right limit is 0.
And they
So
don't match.
And they
Yes.
have to be equal.
Okay, so
this
this
is really
does not
easy.
exist.
Easy peasy.
Wait, I can solve square root x minus 1. Square? No. Yeah, I suppose you do.
Yeah, and then it becomes the square root of 0, which is 0.
Wait, so you solve square root x minus 1 and you square it, so it just becomes x
Okay.
minus 1?
Well, you
So
put the
although
1 in, input it
the
first,
two limits
and then the
on
1
the two sides
minus
do
1
exist,
becomes 0,
yeah,
they
and
do
the square
not
root of 0
meet
is 0.
up, and therefore we say that the combined limit
Yes.
doesn't exist. Any questions about this problem?
Examples.
Yeah, I know, but like,
Why do you have
got it.
the square root of 1 minus x at the top of your graph rather than using the function the square root
Oh,
of
that's
x minus
because
1?
I messed up. Thank you so much. Let's correct this right now. All right.
Oh, yeah, okay.
yeah, idiot. I can't
We're
believe you
smarter
did
than the
that.
teacher. You know why she keeps asking people for examples?
Because she
doesn't
needs
know.
help.
Yeah, she
Needs
doesn't
help.
know.
What an
More than that, if I didn't correct this right now, then what would have happened? This function wouldn't have existed for all these values, for all the values that are higher,
We should be paid proportional to our salary.
higher, further down on this side, right? So thanks. And anytime anyone notices that something is wrong with the notes, pipe up right away so that we can correct it and everyone can have the right notes. Okay, so that everything is correct. Okay, are we done with this problem? Yes?
Yeah.
Any more questions on it? Okay, if you guys are all quiet and guys, then we'll move on.
Look at my little dots on my thumbs from digging. I got it on both thumbs.
Let's try this one. Lim as x goes to 2 of
Is there a bus coming in like 5 minutes?
x
Will?
squared
A 9?
minus 6x plus 8
We gotta get going.
divided by x squared minus 4. Sorry, 4. X squared minus 4.
It was 1209. 1109.
1109. 1109. All right. 1112.
1112?
By the way, is your teacher recording your sessions also?
Yeah.
Probably.
Okay.
Supposedly it takes a
Suggestions.
couple days for
What
me
do
to
we
get
do?
them, so I'll just do it faster and give it to all the students and be like,
You
hey,
can try to
it's actually
simplify
effortless
it
to record it.
first.
You could. Yep.
I mean, maybe finding the factors.
Yes, we could do that. Before that, we could have actually even just say, okay, this is the ratio of two polynomials. Let's try to plug the number in. Okay? So the simplification might be some work, right? So it's probably a good idea to find out whether it's worth your time to do the work.
We still have 5
Okay?
minutes left of this
So
class.
how about all of you take a minute and try to plug 2 in and see what you get, because rule number 7 basically allows us to do that, right?
I don't remember what number 7 was.
Actually, not 7. What is it? Number 8? It's a quotient of two polynomials. It's a rational function.
We'll watch the video. That's why I just want to finish recording.
So go ahead and do it and tell me what you get.
It'd be nice if we could like.
There's a denominator of 0. So
So we have an issue, right?
divide by 0.
So what you're saying is that
Yes.
the suggestion to simplify is probably a very good suggestion, because we can't just proceed simplistically. Just naively plugging in the number doesn't work. Okay? So and this exactly coincides with the provision in that rational function rule, right? It says that it works if the denominator is not 0. But this is exactly what we have. We have denominator 0.
Where's it gonna be? Probably up there.
So we'll definitely proceed with the suggestion to simplify.
It's getting generally equal at stop.
Okay, I gotta disconnect that.
But maybe it'll be a tiny bit late, and this class ends
So we'll
in
get
3 minutes.
x squared
The class will end like a
minus
minute earlier.
6x plus 8.
Then
That will be what, x minus 4 times x minus 2.
Let's just get going.
And x squared
you
minus
guys
4.
can.
That will be
I
x
just want to finish
plus
recording this
2
class.
Yeah, I know what you mean.
times x
Get
minus
everything else
2.
ready to go, and then you can just carry
And
on.
we see that there is indeed a common factor. So we'll have lim
You guys will
as x goes to 2, x minus 4 a times x minus 2 divide by x plus 2 x minus 2. These two factors will go, and we'll have lim as x goes to 2 of x minus 4 divide by x plus 2. Can we now try the rational function rule?
Yes, we can. Just gonna.
Will it work this time?
Yes.
Yes, now we got rid of the problematic factor, and now we'll be able to use the rule that we set down in the beginning. So lim of this divides by lim of the denominator, and we'll get minus 2 divide by 4, and that will equal 1/2.
Cool.
Minus 1/2. The minus is missing right there.
I called that.
Okay?
There's the boss.
Okay.
what's the point of breaking them up like that? Because you could just put the 2 into the x minus 4 over x plus 2.
You can. Yes. So basically.